In this video, we're going to go over something called similarity, right triangles, and trigonometry. And this is just a basic introduction, part one of part two videos that I'll have on this subject. In this particular video, we're going to go over the Pythagorean Theorem, the geometric mean, and then trig ratios, all concerning right triangles. Now, let's start in with the idea of trigonometry because we already know a little bit about similarity and right triangles from previous videos, okay? So what is trigonometry? Trigonometry is basically just the study of the relationships that exist between the sides of a right triangle and the angles of right triangles, okay? And these three concepts here, the Pythagorean theorem, the geometric mean, and trig ratios, are ways of finding the actual sides and the actual angles in right triangles. Okay? So again, trigonometry is simply the study of the relationships of the sides and the angles of these right triangles. Now, let's get right into it. You probably remember from previous study that the Pythagorean theorem says this, that if you have a right triangle, and it's really important that you have a right triangle here, okay? If you were to take the square of the two legs of a right triangle, it would be equal to the square, the sum of the two legs, rather. Let me say that again. If I took this leg here and squared it, and I took the length of this leg here, b, and squared it, it would be equal to this side, the hypotenuse, squared. Okay? And that's pretty much what the Pythagorean theorem says. So we can actually find the lengths of the sides if we know two of the other sides in a right triangle. As an example, let's just go ahead and do one. Let's assume that we know that B is, well, let's go ahead and over here and say that B is a length of 4 units of some kind. Let's say that we know that A is 5 units, and we want to find what C is. Okay, again, C is called the hypotenuse. By the way, the hypotenuse is always located opposite the 90-degree angle of a right triangle. Let's just go ahead and just plug those numbers in. Now, a squared would be that, b squared would be that, and we would solve for c squared. We'll get 25 plus 16 is equal to c squared. Let me just go ahead and write these out according to steps. That's going to give me, step 4, 25 plus 16 is 41. And that's equal to c squared. I'm just going to flip these over. Step 5, c squared is equal to 41. And the way you find the square root of a square is just to simply take the square root, which means that c is equal to the square root of 41. Now, unless you have actual units like 5 inches or 5 meters or something like that, you can just go ahead and leave the square root of 41 as 41. Or if you can reduce it, go ahead and reduce it. But we're just going to leave that alone right now and just say that c is equal to the square root of 41. Okay? So that's using Pythagorean theorem. Now, again, the thing about the Pythagorean theorem is that you need to have at least two of the sides in order to find the third side. And it could just be this one as well. These two can help you find this one, and these two could help you find this one. Now, what it doesn't do, though, is we don't know anything at all about this angle, and we don't know anything at all about that angle. We just simply know that it's a right triangle, so that one of our angles is 90 degrees, okay? And that's absolutely important. Now, there are other ways of finding the lengths of sides if we don't have two of the sides of a right triangle. And let me show you what that is. And you'll recall that we did something called the geometric mean of right triangles. Now notice this is basically the same right triangle, but we have different pieces of information now. What we have now is that we know that this particular side, the C side, okay, and notice how I broke it up, is actually a length of 14. Okay? But we don't know these two smaller sides. So how could we find this information? We can use something called the geometric mean. The Pythagorean theorem here would be worthless, wouldn't it? Now the geometric mean says this. I'm basically going to draw a line from the right triangle, okay, and draw a perpendicular, which means, again, I'm going to draw two more 90-degree angles here and here, directly across to the hypotenuse. Okay? Now notice how I've labeled these. The large triangle is triangle A, B, C. Okay? So let's do that. Triangle A, B, C. But what I've done by drawing this line here, which is called an altitude or a height, okay, so let me just write this over here. H is called the altitude or the height, either one, which is why I'm using H. And by the way, I'm also using the letter H because I don't want to confuse it with this A over here. And you'll notice that the small a is always opposite the large angle A. The small b is opposite the large angle B. And the small c is opposite the large angle C. In this case, the angle C is the 90-degree angle. But anyway, the large triangle is triangle A, B, C. But I've also created two smaller, similar right triangles. And similar just means that these sides are proportionate to these sides. Now I'm going to take that information. Let me just show you how to do that. Now, the second largest triangle is this one right here. So we're going to call that triangle, and let's just follow the exact same order. So we know that C is where the right angle is, and then in this particular case, we're going to call that D. The top, or the short leg, would be C. And then we're going from C to B to D, okay? So this triangle would be triangle C, B, D, okay? And each of these angles would correspond. Let's do the same thing with the smallest of the triangles. Okay, and again, where's the 90-degree angle located? That would be the D, so we're going to put that at the end, just like the C would be here and the D would be there. The top of the short leg in this case would be A, so we're going to put that there. And then down the hypotenuse would be C, so we're going to go, and that would be triangle A, C, D. And again, you have to keep these all in the exact same order, right? And remember that the symbol for similarity is that little symbol right there. So basically we know that these three triangles now are similar in proportion. Now what do we know? The geometric mean basically says this. The hypotenuse of the large triangle is proportionate. The triangle over the long side would be proportionate to the hypotenuse of the second angle over the long side. Okay? Now let me show you how that actually works. We just basically use those two triangles. So we know, for example, that the hypotenuse of the large angle would be 6 plus 8 or 14. And we know that the long leg will be called A. Okay. Now let's look at our other triangles here. And let me do this slightly differently. We know that triangle, this big triangle, looks like this. Okay. We know it's A, B, C. We know that this second little triangle, we just figured it out, was actually, again, in the same order, C, B, D. And we know that the third little triangle, sorry, we just move this over. This little triangle right here would be triangle A, D, excuse me, ACD. My bad. And let me just change that real quickly. Okay, so basically I just rewrote these three triangles over here. Sorry about that. Let me just change that. There we go. Now let's just go ahead and label all these angles. We know that this is B, right? We know that this side here was A, and we know this whole long side was 14. In this triangle here, okay, we knew that the hypotenuse was A. We knew that the long leg was 8. And we knew that the short leg was called H. In the small triangle, okay, we know that the hypotenuse is B. We know that the long leg would be H. And we know that the short leg between A and D is 6. So what we're going to do, going back over here, let me just move this over so we can see it a little bit better. Okay. What we're going to do is we're going to just establish the ratios and see if we can start figuring out some of this information. So we're going to say that the hypotenuse over the long leg, 14 over A, should be similar to the hypotenuse over the long leg of this second triangle. The hypotenuse in this one is 8, and the long leg would be 8. Now look what we've done. We've actually established a ratio with only one variable. So we can actually solve for the A. Let's try it. We'll do cross products. And we know that A times A is A squared. And we know that 8 times 14 is what? 100. And give me 1 second. 8 times 14, I just want to make sure I don't screw this up, is 112, right? Okay. And then I'm just going to take the square root of both sides. And I'm going to end up with A is equal to the square root of 112. Now, you should probably reduce the square root of 112. Okay, and I'll show you how to do that. Basically, what you need to do is, now if there are units involved here, like, inches or meters or something like that, then you would go ahead and just take the square root of 112, which is something a little bit over 10, between 10 and 11. But since we don't have that luxury, we're going to, so we don't have the units, we're just going to reduce it simply. So let me show you how to do that. We know that the square root of 112 is basically the same thing as saying the square root of 2 times the square root of 56. We know that the square root of 56 is basically the same thing as saying the square root of 2 times the square root of what? 28. And now look, we have a perfect square right in there. Let's keep on going. We know that the square root of 28 is the same thing as the square root of 2 times the square root of 14. And finally, we know that the square root of 14 is the square root of 2 times the square root of 7. Okay? So we can rewrite this as the square root of 2, 4, 6, 8. 2 times 2 is 4, times 2 is 6. Let me say it one more time. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can say this is basically just a square root of 16 times the square root of 7. We know that the square root of 16 is 4. 7 is prime, so we'll just leave it as that. Now we have this. We now know that A is equal to 4 radical 7. And now look what we can do. We know that this squared plus this squared will equal 14 squared. Now we can just flip back to the Pythagorean theorem and then solve for B. Okay? Now, but I'm not going to do that because I just wanted to show you that the geometric mean can be used if we only have one piece of information here, simply by drawing this altitude and creating 3 similar triangles, we can actually figure out some of these other lengths. Okay? So now we have the Pythagorean theorem, and now we have the geometric mean as ways of figuring out the lengths of the sides of these right triangles. But there is a third, and that's what I'm trying to finally get to in this particular video, lengthy video. And that is something called the trigonometric ratios. All right, let me just kind of adjust things here just a little bit. So, what are the trigonometric ratios? I want you to memorize this word here, and it's called SOHCAHTOA. Okay? The trigonometric ratios is this observation that the ancient mathematicians had, is that there was a relationship between the angles and the sides of right triangles. Now, let me show you what they were saying. Now, SOHCAHTOA, right, is basically this. The large S is called the sine of an angle. And that's equal to the opposite over the hypotenuse. All right, so we're just going to say sine of just some angle. And they use this symbol here, it's called theta, is just for any angle, right? So the sine of any angle would be equal to the opposite side of the triangle over the hypotenuse of the triangle. Okay? And it's called the sine. Now, there's something called the cosine as well. And again, we'll just say the cosine of any angle would be equal to, according to this, the adjacent side over the hypotenuse. And then finally, the T stands for something called the tangent. So tangent theta is equal to the opposite side over the adjacent side. Now, let me work a problem so you can see exactly what these 3 trigonometric ratios or trig ratios mean, okay? Now, in a right triangle, we know that we had a 90-degree angle, right? That was a given because you have to have these can only work with 90-degree angles or with right triangles. If you happen to know one of the other 2 angles, like for example, this one was given as 60, we know then therefore that this angle has to be 30 because one of the properties of all triangles is that the internal angles all equal 180 degrees, right? So according to this, we can figure out these sides simply by saying the sine of 90 of just take any of these angles. Let's just take 60 degrees. So we'll say the sine and we don't normally put the E in there. So we'll say the sine of 60 degrees will be equal to the, in this case, the opposite side, so we'll call this little b, over the hypotenuse side, which we'll call this one little c, okay? So we'll just say this length over this length, b over c. We'll need one more piece of information in order to do this. So in this case, let's just say that we know that b is equal to, let's go with 4. Okay, a length of 4. And let's say we didn't know anything else other than just the angles. We didn't know this length and we didn't know this length. And we can't even draw the geometric mean here. We can't use the Pythagorean theorem here. So let's see if we can use a trig ratio. So we know that the sine of 60 degrees would be equal to 4 over c. Okay, so let's fill that in. Now, what is the sine of 60 degrees? To do that, you just go to your calculator. And you'll notice on your calculator there is a button. It's called sine. All right. So you punch in 60, or sine rather, excuse me. So you'd say sine 60 degrees, and then you'd press enter. And you get 0.866. Now that's going to be true no matter what right triangle you have. This could be, 45 degrees, this could be 30 degrees, it could be 22 degrees, it could be 1 degree. But the sine of whatever that degree is will always equal some kind of a constant number. So now we know that the sine of 60 degrees is 0.866, and that's equal to 4 divided by c. Now you just use your algebra, and let's just solve for c. So that'll be my step 1, my step 2. My step 3 is we'll just multiply both sides by c, and you get c times 0.866. If you multiply that by c, those cross out, and you get 4. Let's divide now by 0.866. So you get c is equal to 4 divided by 0.866. Let's just try that real quickly. 4 divided by 0.866, and that's equal to 4.619. And we'll just say 4.62. Okay, so now we know that c is equal to 4.62. And now look what we can do. We can actually use the Pythagorean theorem again and say that this side, which is little a, plus this side, which is 4 squared, will be equal to c, which is 4.62 quantity squared. Okay, just simply by using a trig ratio and by knowing what the angles were inside. And you can do that with any of these angles. Okay. Now, that was quite a bit of information. Basically, just remember that the idea behind this whole video is that there are relationships that exist between the sides of right triangles and the angles of right triangles. And you can find the sides of right triangles by using the Pythagorean theorem with certain pieces of information, or you can use the geometric mean to find the sides of the right triangle, right? If you have certain other types of information, or you can use trig ratios to find the sides of right triangles using certain kinds of information, right? And you have to decide which one of these 3 methods is the best way to go depending on the information that you do have. Now in part 2, what we'll do is I'll show you how to figure out what the angles are if you know what the sides are, okay? I know that was quite a long video. I hope that was helpful.